Take a look around you for a second. That window frame over there, the case on your laptop, maybe even parts of the car you drove today. Well, there's a really good chance they were all shaped by this incredibly powerful yet kind of elegant industrial process. Today, we're going to pull back the curtain on that hidden world, the incredible journey of aluminum extrusion. We're going to see exactly how a simple log of metal gets transformed into the complex shapes that literally build our world.
So, here's our game plan. First, we'll break down what aluminum extrusion actually is. Then, we're going to follow a single piece of aluminum, it's called a billet, on its wild journey from a solid block to a finished product. After that, we'll see if it can survive the intense quality control gauntlet. And finally, we'll connect the dots and show you where this process pops up in your everyday life.
All right, first things first, what are we even talking about when we say aluminum extrusion? Let's get right to the heart of this really cool manufacturing method. I mean, really think about it for a second. How does a raw material like a hunk of aluminum become something as complex as a window frame or a heat sink with all those tiny, perfect fins? You know, it's not carved, it's not melted and poured into a mold like you might think. The secret is extrusion. At its core, the idea behind extrusion is actually super simple. The best way to picture it? Think of a giant industrial-strength Play-Doh press, but for metal. You take a softened material, in our case a heated-up log of aluminum, and you push it with an incredible amount of force through a specially shaped opening. That opening is called a die, and what comes out the other side has that exact continuous shape, or what we call a cross-section.
Now, to make all this magic happen, you really just need 3 key players. First, you've got the billet. That's our hero, a solid cylindrical log of raw aluminum alloy. Then you have the muscle of the operation, the extrusion press. This is the machine that provides all that insane pressure. And finally, you have the artist, the die. It's basically a hardened steel disc with a precise cutout that defines the final shape of the part.
And the shapes that die can make? Well, they pretty much fall into 2 main categories. On one hand, you have a solid profile. You know, think of a simple angle bracket or a solid bar, one continuous piece. And then you have the really complex stuff, a hollow profile. This is any shape that has an enclosed space inside, like a square tube or those intricate parts that make up a modern window frame.
Okay, so we've got the basics down. Now let's actually follow our billet as it starts its big journey. This is where the real transformation happens, where a simple cylinder becomes a highly engineered, super useful product.
So here it is, the whole sequence laid out. It all kicks off when the billet gets heated to around 500 degrees Celsius. That makes it soft and workable. Then it's loaded in. The press applies just immense pressure, we're talking thousands of tons, forcing that soft aluminum to the die. As this long, newly shaped profile comes out the other side, it's immediately cooled to lock in its properties. But wait, it's not done. To get rid of any internal stress and make sure it's perfectly straight, it gets gripped on both ends and stretched just a little bit. And only then is it finally cut down to the exact length that the customer ordered. But, you know, just creating the shape is only half the battle. Now our brand new aluminum profile has to face its toughest challenge yet, the quality control gauntlet. This is a whole series of tough checks to see if it's actually good enough to be sent out into the world. And I really can't overstate this enough. In any kind of high-precision manufacturing, quality control is, well, it's everything. Just one tiny little flaw can compromise the safety and integrity of a final product, and that could be anything from a skyscraper to a bicycle. So yeah, this inspection step is absolutely critical. So what exactly are they looking for? Well, a few big things. First, is there any twist? You know, a spiral distortion where the profile isn't perfectly straight. Is there a crack? That's an obvious structural failure. Or are there any of the more subtle surface defects like scratches or blemishes that could ruin the look or even signal a problem with the die itself? To check for these tiny, tiny imperfections, an inspector's best friend is the caliper. This amazing tool lets them take incredibly precise measurements. We're talking down to fractions of a millimeter. They use it to check things like the gauge, which is just the thickness of the profile's walls, and to verify its overall straightness, making absolutely sure there are no bends or twists at all. So after all that, the heating, the pressing, the cooling, and the stretching, we finally get to the moment of truth. Has our billet's whole journey been a success? Is it going to pass this final, crucial test? And if any of those defects are found, the outcome is simple and it's absolute. Reject. The piece gets scrapped. Now, this can happen right there on the factory floor during that first inspection, or sometimes a defect might slip through and be found later, which leads to a customer complaint. And that, you can bet, triggers a much deeper dive into the whole QC process.
But if it's perfect, if the dimensions are spot on, it's perfectly straight, and there's 0 defects, then it gets the green light. It passes inspection, and it officially becomes part of a completed order, all ready to be shipped out and become part of a final product. That's a successful journey.
All right, now for the really fun part. We've seen how it's made, but why does any of this actually matter to you? Let's connect this whole industrial process directly to the world you live in, from the factory floor right to your front door.
The list of where you find extruded aluminum is, well, it's massive. We're talking about the frames for your windows and doors, the heat sinks that keep the processor in your computer from melting, lightweight structural parts in cars, the frame of your bike, the sleek metal case of a laptop, and even the frames that hold up solar panels. I mean, it is absolutely everywhere.
So, I'm going to leave you with this final thought. Take another look around you, right now. Now that you know the story of the billet, the press, and the die, what do you see? What's an object near you that started its life as just a simple cylinder of aluminum before it was pushed into the exact shape it holds today? It's pretty cool when you think about it. Thanks for tuning in.